Hello everyone, good evening. I hope I'm pretty much audible as well as visible to people. As well as visible to people. Right, so just setting up the screen, guys. Give me a minute. Just okay, so looks like we're pretty much good to go. So thank you so much for joining us. Hello Shubham, good evening. So a very warm welcome to everybody once again. So today we are going to talk about statistics. So our prime agenda for today is statistics. So where we will be talking about how statistics is basically used in day-to-day job here and in data science, what exactly statistics mean, right? So we will be talking about all of that in detail. So we'll quickly do that. Looks like some video issue here, guys. Just give me a minute. I'm setting that up. Just give me a minute. Hey guys, welcome back. Apologies, I think there was some technical challenge. So there was some issue with my video feed. So I hope I'm pretty much visible as well as audible now. Okay, so let's get started. So today we are going to prominently talk about statistics, guys. So there are so many different skills which is needed for your data science profile. So we have been talking about machine learning quite a bit now. We talked about Python. We also talked about SQL a bit. Now it's also important to understand, to start your data science journey, statistics also plays a very, very, very important role here. So we will be talking about how statistics is actually used, what are different things are there in statistics, and how exactly we will be using statistics for our own purpose here. That is pretty much what the agenda of this discussion is, guys. So one thing which I want to really clarify, I have been hearing a lot many times from people here that statistics, by statistics, we try to tend to understand it's more towards mean median mode, right? So by statistics, what we have been studying so far is nothing but mean, median, mode. But trust me, guys, statistics is way beyond that, right? There's so many different concepts in statistics, which is pretty much needed for you to understand. And in fact, when you want to start your career in data science, statistics is something which is very much important. So we will be talking about statistics in detail in our today's class, and we'll try to understand what all different concepts are there in statistics, which makes it more usable and important in data science part. Okay. So let's get started. But even before that, my name is Arpit Jain. And the reason why I'm here with you all, because I really like sharing my expertise with people, and data science is what my passion is. Technically, I have around 10 plus years of industrial experience into multiple different domains, and currently working as a lead data scientist myself. And then definitely I do like talking to people, so I'm a public speaker as well. So if you have any concerns, anything in general also, please feel free to reach out. It's pretty much a live session, so we can always talk about the things, whatever you have. Okay, so with this, let's get started. So today's agenda is prominently towards statistics. So we are going to talk about what is statistics and how exactly we are going to use statistics. Okay, so in statistics, I'm going to first talk about few of the important keywords. So something called as EDA in data science. Okay, so statistics, how statistics is important in EDA, exploratory data analysis. So we will be talking about that, some various different steps in EDA. And also statistics prominently is of two types. We talk about descriptive stats, and then we talk about inferential stats. So we will be talking about both of these two different topics, descriptive statistics and inferential statistics, in detail. And we will try to understand how these two are important for my data science profile. So we will talk about each of these concepts. And we'll also try to understand another very important topic in statistics, which is important for you to understand the data science part, is probability. Right? So we will be talking about probability. So we will introduce you to different important keywords in probability, and we'll try to take some examples here and try to solve it as well. And at last, we will talk about again something which is very important, which is nothing but central limit theorem. Okay, so we'll talk about this as well. So all of these is prominently my important properties and parts of data science. So we will talk about each one of them in detail. So descriptive statistics, inferential statistics, and also we will be covering, in fact, the EDAs on top of that. Concepts of probability, and at the last, we will talk about central limit theorem. So that's prominently what we are going to cover. But in anything in general also in between, it's pretty much a live session, guys. So please feel free to reach out. It's pretty much a live session. I'm monitoring the chat so we can take up your questions likewise. Okay. So moving ahead, let's quickly understand what is statistics. Okay. So statistics is nothing but is a set of rules and concepts for analysis and interpretation of the data. So now understand this thing. When we talk about data, right? So data could be in different formats. I could have, qualitative data or a quantitative data, or what different types of information I have. So the objective of this statistics is basically to help us analyze and interpret the data which we have. So obviously these rules and these concepts will change according to my data type, right? So if the data type is, say, qualitative, I'm going to prominently talk about some statistical measure which is going to be revolving around some strings, some textual data, right? At the moment when I say it is talking about my quantitative data, so I'm talking about numbers. So statistics is basically all those rules and concepts which is helping you to analyze and interpret your data, as simple as that. And obviously, for each of them, we have so many different concepts involved, so that there's so many different rules, so many different concepts, which is helping you to analyze your data. So what is my end objective? I need to analyze and interpret the data. What do I have? And for this purpose, I have so many different things. I talk about univariate analysis. I talk about bivariate analysis. I talk about some experiments. I talk about some population estimation. And that is how we talk about the different things in statistics as well. So let's quickly start with each one of them. So I'm going to first take univariate here. Okay. So let's take univariate analysis. So what does a univariate analysis means, guys? So univariate, as the name suggests, uni plus variate. That means uni means one, variate means variable. That means I'm trying to analyze one variable at a time. That is pretty much what is going to be called as univariate analysis. And if you go back here, let's try to see in univariate analysis also we have certain different things: central tendencies, distributions, and spread of data. Let's talk about each one of them. So I talked about central tendency. That is pretty much prominently where these three topics comes into picture: mean, median, mode. Now think from a data perspective. I have a data set. I have, say, whatever X data set, and I have multiple different columns here. Okay. So I have multiple different columns here. I think I just messed this up. Just a minute. Yeah. A data set, multiple different columns are there. So suppose my column 1, column 2, and whatnot. So suppose my one column is, say, age. Okay. And I'm trying to analyze my date column here. Sorry, my age column here. So, and in this age, I have hundreds of records. So all of these persons, so age 31, 36, 37, 45. So all these ages of my entire population is given. So I'm trying to analyze my age column alone at a time with these central tendency measures. So by that, what do I mean? What is the mean of age? What is the median of age? What is the mode of age? So what is the mean? Mean is nothing but the average value. And how do we calculate the average? So mean has a formula which is nothing but sum of all values divided by total number. So in statistics, you have to keep one thing in mind. There will be few formulas. Obviously, few basics of them you might need to remember that. But again, it is not 100% mandatory to remember every single formula. But obviously, being a good data scientist or analyst, you are expected to kind of logically understand those formulas. Okay, so likewise, mean is very simple formula. Now I'm trying to find out with the mean of my age column. So suppose I have hundreds of records and sum of all those ages is, say, 2000, and I have 100 records. So 2000 by 100. So average is going to be 20. So my average age of the entire population is 20. So that is measurement of one central tendency in my univariate analysis. Likewise, I can talk about median. Median is what? If I have a data, 100 data, sort all of them in increasing order. We talk about the middle value here. So what is that? Suppose I have this 100 values and the middle value is, say, 35. So median is 35. Then mode, I talk about the maximum occurred value. Out of my entire list, what is my maximum occurred value? Suppose now I have 100 values. Out of 100, I could see 32 has occurred 20 times in my data. That is the maximum occurred value in my entire data set. So I could see that now 32 is one of those ages which is occurring multiple times in my data set. So mode is where I'm going to say that the maximum occurred value. So mode will become 32. So the moment I clean up this, I clean up some unwanted ink here and want to show you what just happened by this. Yeah. So now with this calculation, we have actually turned out to be having three numbers. Mean, we figured out 20. Median, we figured out 35. And the mode, we figured out 20. So how exactly these values are changing, that is what pretty much I'm trying to find out here. Guys, am I audible as well as visible now? Okay, cool. Thank you so much for confirming, Shubham. Apologies for, I just got disconnected. There was a power fluctuation here. Okay, so yeah, what I was saying is, after doing all those calculations, if you could realize, I have summed up to three different values: mean, median, and mode, right? So I found out three different values. So this is one way I'm trying to analyze my data. So after doing all those mathematics, now I figured out three standard values which is descripting my central tendencies of my one variable. So likewise, once we start analyzing my entire data set, I try to figure out these central tendency values for all of my different variables. So obviously this has certain meaning in it, right? So by mean, median, mode, and then we try to further understand the second part of my univariate analysis. That is where we talk about it as distribution. Very important topic. So if you go back here, so we talked about central tendencies. So central tendencies, we have mean, median, mode. Now we talk about distributions and the spread of data. So what do we mean by these distributions? Going back here, so now in this distributions, same data set, I have hundreds of values. I'm talking about, say, age column. And age column, I have the values such as mean, median, mode, right? So what I'm talking about, I'm having these three values, and then I'm trying to understand how the entire values are spread across. When I say spread across, so I have, because I'm not only having one value, I'm talking about having multiple different values. So when I talk about this age column, I have 100 values, right? So suppose out of these 100, one is 20, 23, then I have 32, then I have 35, 41. So if I try to kind of plot this entire data, by plotting I mean I'm trying to visually analyze my data. So I have my total range. So starting from, say, 0, I have maximum of 100 as age, and all of my values are actually lying between this range. So by distribution, what happens, we try to bifurcate them into smaller bins or smaller groups. So that means I would make some group as 0 to 10, then I make another group as 10 to 20, then I make another group as 20 to 30, then 30 to 40. So likewise, I make 90 to 100, 10 different groups. And then we try to check the frequency or the occurrences of values in these different bins. So suppose what I've understood is my data set here, it says out of the values 0 to 10, I got 5 values. 10 to 20, I got 9 values. 10 to 20 to 30, I got 13 values. So likewise, I'm able to get all the frequencies. So I have two things here. First, I have the range, and second, I have frequency. You're getting it? So I'm trying to find out in two different things, the ranges of my values, how many occurred different ages are there in my entire data set. And the moment I try to plot this, so same data set, if I want to plot this here, like this, sorry, my bad. So if I want to plot this, in this graph, I have 10 different bins. So first bin is like, say, 0 to 10, like this. And then I'm going to talk about 10 to 20. And likewise, I have 20 to 30 until the end part, 90 to 100, right? So in 0 to 10, what I'm saying is I'm having 5 values. 10 to 20, I'm saying I'm having 9 values. 20 to 30, I'm saying I'm having 13 values. So likewise, I'm trying to check the data, how it is getting plotted. You're able to understand this? So in this graph, what I have in the x-axis is the range, and in the y-axis, I have frequencies. So basically, I'm trying to check the distribution of my values based on each ranges and my frequencies, right? And with this, what I'm able to get, it is kind of following something like this trend. So this trend is what we call as distribution of my data. Okay. So obviously, there are multiple different trends. There could be a curve like this. So if we talk about in terms of different types of informations, like what are different types of curves are there. So from that regard, if I have to say, I can, by this graph, I can say that this is following what? A simple bell curve, like a bell-like curve. So here it is increasing and then decreasing in an even fashion. We call this as a bell curve. So this bell curve is also called as normal distribution. Second, we can also talk about some skewed data. Skewed data, by that I mean the curve which I'm talking about, this is not normal. This could be like a peak in the beginning and then I have something like a tail at the end, or I could have another curve where I have a tail in the beginning and then I have a peak towards the end, right? So skewed data where I have tails. Okay, so this is with the tail, if there is in the right side, we call this as right skewed data. And if the tail is on the left side, we call this as left skewed. So basically in this skewed data, we talk about there are certain peak towards not in the middle part, towards the beginning or towards the end. And then we have few points which is way off the normal values. We call these tails also as outliers. These are my unwanted, not so normal, not so unwanted, I would say. I would say these are my values which is not in my normal ranges. So most of my values are lying towards this area where I have the peak, and then we have very few values which are towards the extreme. So these extreme values are also called as outliers. Okay, so that's pretty much how do we define our statistical part. So that is where we call the distributions of my univariate analysis comes. Okay, so in this univariate analysis, what do we talk about? We try to understand two very important things: the central tendencies, and then we try to understand the distributions of my data. The distributions, again, how the values are distributed over different ranges. The second comes about the bivariate analysis. So bivariate analysis is nothing but we are trying to establish the relationship between the multiple different variables. So what does this mean? So now let's try to understand even this part. So going back to my graph again, so I'll put one more new sheet. So let's talk about bivariate here. So bivariate analysis, again, same data set. Suppose I have a Excel file, and in this Excel file, I have multiple different feature sets. Suppose I have, say, ID, age, name, phone number, salary. And what I want to do is I want to now understand not only the single column, because bivariate means what? Bi plus variate. That means bi means two and variate means variable. So now we are trying to analyze two variables at a time. Two variables analysis at a time. Right? That's what we're trying to find out here. So now what we can do multiple different combinations. We can try to see how age is interacting with salary, and lot many other combinations can be prepared depending on your data. But here the intent is, suppose I'm trying to analyze how my age varies with the salary. Suppose this is my age column. Now, for both X and the Y axis, I need to pass the columns here. So some of the other features I'll be passing in my X and the Y column. So I want to find the relationship between two variables at the same time. So now I say age here in the X axis and maybe salary here on the Y axis. Okay. So now what I'm saying is, suppose my age is starting from, say, 0, 20, 40, 60, 80 and whatnot. And then likewise salary is also increasing here, 20K, 40K, 100K and whatnot. So ultimately what I'm able to see is, for the data points, this is how the graph is coming. Okay, all the data points are coming like this. So basically I'm able to see, as long as my age is increasing, my graph of salary is also increasing. So it's more like a relationship with salary for age. So we are trying to find out the relationship of salary with my age. My objective is I'm trying to see with every passing age how my salary points are changing, right? So I'm trying to figure out the relationship here, and as you can see here in this relationship, it is pretty much going straight upwards. So as long as my age is increasing, depending on this data, whatever data I have, it says that my salary is also expected to increase. So that is a concept of bivariate analysis, guys. So in this bivariate analysis, there are so many different options of graphs are available. So I'm just talking about one kind of graph here. We have two numbers. This graph is called as scatter plot, but we have so many different options available. This is called as scatter plot, but we do have box plot, we do have a bar plot, violin plot. So many different graphs are there, so which actually helps us to analyze and do our bivariate analysis. Okay, so we will go that in detail with time, but the objective of bivariate analysis is where I'm trying to see these individual variables now in combination with each other. So I'm trying to establish the relationship between the two variables now here. That is pretty much what the objective of bivariate analysis is. Okay, so going back to my first slide here, then we talk about experiments. So experiments is where the need of hypothesis testing comes into picture. So we talk about t-test, we talk about z-test, we talk about chi-square test, one pair, two paired, one sample, two samples. So many different experiments are there. So we basically try to compare how two different data sets are similar to each other. So basically in this statistics, the comparisons happens, the similarities, we try to compare the similarities between two different samples, and that is where the experiments comes into picture, right? So again, so many different things are there, so we will be reading all of these with time. And then at the last comes the population estimation. That is where we talk about the central limit theorem. So we will explain the central limit theorem towards the end of our class also. But now moving ahead, let's try to understand the two different types of statistics, guys. So we talked about descriptive stats and we talked about inferential stats. So descriptive stats, when I say, it is nothing but it is purely talking about the summarization of the data in my hand. So whatever data I have, I'm trying to put a summary around it. Like for example, I said mean of my data, I talked about median of my data, I talked about mode of my data, right? So those are the summary points which I have, correct? So this is one way of talking about my data points in statistics. So summarization by putting the descriptive stats around it. Likewise, in inferential stats, we talk about taking the inferences, the approximations from the population estimate. What does it mean? Now, suppose that I want to find out mean of the age of entire population from India. Mean age of entire country India. So what is the entire population of India? 1.3 billion. So is it statistically possible to carry out the experiments and to carry out the mathematics and the numbers for each and every individual from the country? Becomes really tricky and next to impossible, right? So a situation where we have so many data points where the calculation is next to impossible for the entire population, entire piece of information which we have, then in those scenarios, we try to take samples out of them. So there is a technique called as sampling, which is very important. So there's a new keyword called as sampling. So sampling means I have a bigger population, and from that bigger population, I'm trying to take certain subsets. Okay, and obviously there could be so many methods in which I can take the subsets. So again, likewise for that, sampling also has multiple subtypes. Different types of sampling are there. Again, we will be dealing with this in detail. But moving ahead, talking about my descriptive stats. Okay, so the descriptive stats, it is comprising of these four different things. So whatever we talked about in terms of univariate analysis, also and the bivariate, it is comprising of descriptive stats here. They all comes under descriptive stats. So I talked about mean, I talked about median, I talked about mode, I talked about distribution. And not only these, I could have standard deviation as well. I could have variance, I could have percentiles, I could have count. So all of these, in fact, I could also talk about minimum, maximum. So all of these descriptive stats which you can think of, right, is pretty much part of my descriptive stats. Descriptive means I am describing my data in some or the other way. So these numbers are actually describing my data, right? These are my description of my data. By central tendency, this is what I mean. Spread of data, I mean I'm talking about how the data is distributed. And that is where we talk about the definition of my distribution, normal distribution. That is where we also term this as a Gaussian distribution. And then we have certain skewness. That's where the right skewed, left skewed information comes into picture. So all of these things becomes very important. Pretty much part of my descriptive stats. And then we talk about inferential statistics. That is where prominently we talk about approximations, sampling, and error analysis of my sampling. So we try to understand how this thing helps our job. So suppose now I talked about entire population of my data. So I have my country. So I have north region, I have east region, I have west region, I have south region. So I have my entire country spread across these four regions, right? And now what I'm trying to understand is for this part, for the entire population, if I want to find out the mean of age. And we understood, obviously, finding the mean of age is statistically next to impossible for all the different populations here, all the different individual here, because getting the values of all of this again will become a tricky thing. That is where we talk about certain approximation, sampling of my things. So sampling again can be of multiple different types. So we talked about random sampling. We have something called as stratified sampling. There's different methods in which we try to add the sampling part. So I'm just going to list down a few of them. First is random sampling. So by random sampling, I mean any value from entire population. Suppose that I have total of 1.3 billion people, and out of 1.3 billion, I want to take out 1 lakh. So that means any 1 lakh from this entire 1.3 billion will be my random sample. Any 1 lakh value, any value. But think logically. There could be a possibility that out of these 1 lakh, somehow I only took those people who are towards their mid 60s or mid 70s. So by doing this, I have a unwanted biasness because majority of my representation, majority of my people from this sample are old age people. So obviously my mean will be high. But is this the right representation of my data? No, might not be the right representation of my data, right? Because I'm randomly taking any value, and any value could be anything here. So, and that is where we have another second bit advanced method of sampling comes, called as stratified sampling. So in stratified sampling, what happens, if you remember, we had this part. So we had north, east, west, south, right? Suppose that in our 1.3 billion of data, I have 30% from north, and 20% from here, and then again 30% from here, 20% from here, whatnot. So just giving you the vague figures. And when we take the samples, right, I will have the equal representation. So if I'm going to take 1 lakh rows, so out of 1 lakh, 30,000 will be from north, another 30,000 from west, another 20 from east, and another 20 from south. So basically, the proportion of these data sets across each of these categories will remain the same even after sampling. And I can think about it from the age perspective also. Suppose I say elderly people, I have different ages group, right? So if I have a certain representation in my population, that representation will also be pretty much valid in sampled data as well. That is where stratified sampling comes into picture. Another bit advanced method based on the sampling technique. Likewise, we have few more methods, guys. Obviously, we can keep on reading about that. But the main understanding point is, in the inferential stats, we talk about the approximations, the sampling of my information. That is where from the entire population, we try to get into some specific pointers. Now, the next is EDA. EDA is very important. That is what we do on the data set. We talked about exploratory data analysis here. So in EDA, exploratory data analysis, we do many things, and that is where statistics comes into picture. The very first thing, the moment we start analyzing our data, the very first thing is I talk about variable identification. EDA and EDL are two different things. It's not EDL. If I'm able to understand your part, Shubham, it is ETL. Yes, ETL, correct. So ETL is different. ETL is part of my database concept: extract, transform, load. So basically, what happens here in this case, in extract, transform, load, we have a data source. We are extracting the data, and then we are transforming it. Yes, transforming could involve some of the steps from EDA, and then we ultimately load it back to my database. So that is the concept of database, ETL. But EDA is exploratory data analysis. That's where I'm trying to analyze my data. Okay, and these are the few steps. Like, for example, the moment I load up my data, I need to identify my variables. I need to perform the univariate analysis. I need to perform the bivariate analysis. I need to do some feature cleaning, like missing values treatment, outliers treatment. I need to create some new features. Feature engineering will also be part of this here. So this is what EDA comprises of. But ETL is prominently towards the extraction, transformation, and the further loading of my data, whatever we do that. Does that make sense, Shubham? Are you able to get this? Okay, so coming back here, if you try to look at the parts of my EDAs, so we talked about the variable identification. So it's more like data type identification. So strings, strings, numbers. So it tries to identify what is my data type. Then all sort of univariate and the bivariate analysis. So we talked about central tendency, we talked about distributions, we talked about correlations, multiple relationships. All of this will come here. And then we perform certain feature cleaning steps. That's where missing values. So we do have missing values in my data. So we try to either replace the missing values or we try to drop the missing values. Again, it has certain strategies. So replacement or dropping depending on my requirement. Then we talk about the outliers, where we said it's more like an extreme values, right? And then we extremely talk about the correlations. We do have the feature engineering. In feature engineering, we talk about both reduction and we talked about creation. So reduction by that means, suppose I have thousands of features. Obviously, thousands of features are too much. We try to reduce those features. There are a lot of mechanism are also involved here in reduction techniques. A lot of different techniques are there. So that include PCA, something called as PCA, factor analysis, right? And then in creation, it's pure towards my business knowledge. So domain knowledge or business knowledge comes into picture here, and that is how we're going to create some new feature sets in my data part here. So that is how we define the different feature engineering steps, guys. So that is basically how we do the EDS, and obviously there are many things are involved here, so that will be covered with time. But now the last topic which I want to cover for today is going towards my probability, right? So probability is again very important topic of my statistics. So we talked about events, we talked about sample space, we talked about experiments here. So what does that mean? So probability is nothing but chance of any event being happening. Now, for example, suppose that I have a deck of cards, and in this deck of cards, I have what? 52 cards, right? And this 52 cards are further divided into four different categories. So diamonds, spades, hearts, clubs, and each one of them has 13 cards each, right? So now, what if I say I am drawing one card out of my deck of cards? So what is my total events? So the total possibility or total possible outcomes is what? 52 cards. I can have any of them, right? That is what is called as sample space. Total possible outcome. That is my sample space. An event, favorable event, is what is expected. That means one card here, that means one become my favorable event. So my probability becomes, formula of probability is nothing but my event divided by sample space. So out of this sample space, I have total of 52 cards. So what is the probability of taking one card out of my entire deck? 1 out of 52? Any deck, any card? But again, if I say, what is the probability of me taking a diamond? Right? So what is the probability of me taking a diamond of my entire events? So in total, I have 52, but out of 52, I have only 13 as diamond, right? So I can probably choose any of this out of my part here. So what could be anything? What could be this part? So my total favorable cards are 13 and my total sample space is 52. So out of 52, there are 13 cards through which I can choose diamonds. Likewise, what is the probability of me choosing a spade? Even for that, I have 13 favorable events, and then total sample space is 52. So 13 by 52 is my probability. Or talking about a very simple example, let's forget about all this. Let's take a very simple example, coin toss. I have what? Heads and tails. So what is the probability of me getting a head? So again, formula is what? Number of favorable events by total sample space. So what is my favorable event? Out of all of these two, only one is my favorable event, and total sample space is what? 1 plus 1, 2. That is coming 0.5 or 50%. Right? So probability of me getting a head is 50%. So that is how we define the probability, guys. And likewise, we have so many concepts involved in probability as well that we will cover with time. But these are my very standard topics which you, being a data analyst or a data scientist, must be aware of about statistics, guys. This is technically what I intended to cover today. I'm open to questions, any questions which you want to ask. I'm happy to take it. But technically, guys, this is exactly what we are trying to look at. So we are trying to understand the different parts here. We're trying to understand how we can use the parts for our data science part here, guys. So please feel free to ask any questions. Conditional probability, yes, obviously we can talk about conditional probability, but I'm intended to cover that in the next class. But again, I can talk about that. So basically, conditional probability, it talks about event being happening in contradictory for something. For example, when I say probability of A being happening when B has already happened. So we write this as A or slash B. That means B as an event has happened and A has to happen. So what is the probability of me going to play cricket if it is raining? So there are two activities which are happening. So B is the event which is raining, and I say A, play cricket. Right? That's where the concept of conditional probability comes. So we call this as P of A by B. I think this messed it up. Just a minute. Yeah, the formula is P of A by B. We write this as P of B by A multiplied by P of A by P of B. So again, I'm not going too much in detail about that, but that is how we talk about the conditional probability. So we talk about two events basically here, A and B, and then we try to understand, okay, if one thing has happened, based on that, how the other thing will happen. That's a concept of conditional probability. Next lecture topics, Shubham. So this is one thing which I wanted to cover. Let me just quickly check. Yeah. So we will be talking about data visualization, big data, something about inferencing, unsupervised learning, deep learning, neural networks, text. So lot many new things are coming up. So I'm intending to introduce you to all of these concepts, and then eventually with different respective courses, we'll go deep in each of these concepts when and if required. The objective is to give you a clear idea about how all our different concepts or different things are there in data science field. Okay. Any other questions, guys? Cool. With this, thank you so much. Thank you so much for being patient and listening to me. Yes, I'll take your feedback, Shubham. One lecture on projects and resume as well. So yes, in fact, resume is also expected to be covered for data science, and projects also. Yes, I'm trying to take up a session on live projects as well. So let's try to do that. So I'll take up that. Yes, Raj. So there are fixed timelines. It is basically Monday, Wednesdays, and Fridays, technically coming live. Okay. So that's pretty much when we try to come live. How to prepare for DS and DA interviews? I would say that you have to prioritize 4 skills here. Python SQL for the coding rounds, and then we're going to talk about statistics, machine learning in terms of your hands-on experiences. So try to target these 4 skills, and that is where the interviews are also focused around. So coding rounds will be there on Python SQL, and then the discussions prominently around EDA, stats, and machine learning. Sure, Shubham, I'll check that. Cool, great, wonderful. Thank you so much, guys, for asking so many questions. It was lovely interacting with everybody again. So see you on the next day with a new topic, and then we'll go ahead from there. And as always, we'll keep on interacting likewise. Thank you so much, guys. See you in the next video. Bye-bye.